Okay, so here is our last lesson in medical math. It is on IV infusion rates. Okay, so the definition of an infusion rate is the rate at which fluids and medications flow through the needle drip into the patient's bloodstream. And we're going to look at a picture of a needle drip and how everything is set up with an IV bag in general here in this PowerPoint, but then also in your lab application coming up in week 6. So types of infusions that we're going to be talking about and that you will have to calculate are the surgery infusion rates and also fluid replacement therapy infusion rates. These are two completely different formulas with some things that are the same within the formula, but they have different rates involved, and we'll get into that here in just a minute. So drip sets. Drip sets are very important because depending on the size of your animal will depend on the drip set that you grab to actually deliver the fluids to the animal. So your drip set parts include, let me just grab a pen here. Will include the drip chamber. The drip chamber is this clear area that you can see here. These are drip chambers. The needle bore is where the drip actually comes out. So you see there's a tiny little needle that's delivering tiny little drips into this drip chamber, whereas here this is like a wide open hose that's delivering larger drips here. So that the needle bore is the size that through which the drips drop into the drip chamber. The line is the plastic cord that runs all the way from the IV bag to the patient. The roller clamp, this is the roller clamp here, and there's a little rolling device here on this clamp, and the rolling device, if it's all the way up at the top, that means that you're allowing fluids to rush through wide open through the IV line here. If it is down partial, part of the way there, basically you're allowing only so many drops to come through the line into the drip chamber. And if it's all the way down here at the bottom, you've completely clamped off and closed this line, so no fluids will be delivered to the patient. There is also something called a slide clamp. A slide clamp is not actually shown here on this picture, but I'll show it to you in person during your lab application. And so your slide clamp is kind of, it's almost like this roller clamp, except you can clamp the line much faster than if you had to roll it down here with the roller clamp. So I will show you that whenever we get into our lab application so you know what a slide clamp is. Basically, again, it just closes off the line very quickly in cases of emergency or something like that. Adapter for the catheter. This is this orangish, yellowish, golden area here at the end of the line. It will basically, this adapter will connect to the catheter that is inside of the animal's arm. So here you can see it's adapted to a needle, which is common as well. So this is basically the adapter is where the catheter connects to the IV line. Now your basic drip sets that you are going to need to know, absolutely need to know for your calculations for infusion rates are large bore needles and small bore needles. Now your large bore needle looks like this. Again, it's like a hose that is wide open. Nobody's clamping it or kind of bending it shut. So, sorry, my pen is not working here. So the large bore needle, it delivers 15 drops per ml. So in 1 ml that flows through this drip chamber, there's going to be 15 drops. So if you count 15 drops that come through, that's actually equaling 1 ml. And we use this for animals that are 20 pounds or greater. So if you have an animal that is 20 pounds, you would use a 15 drop per ml drip set here. So if it is greater than 20 pounds, you're also going to use this. Anything less than 20 pounds, you're going to use a small bore needle. Your small bore needle is this little tiny needle drip right here. So this is going to deliver 60 drops for 1 ml. So if you were to count 60 drops that come through this chamber, that would equal 1 ml. So we use this for smaller animals so that we're not overloading the animal system with IV fluids. So again, you must know 60 drops per ml for animals that are less than 20 pounds. So for a small animal, you're using the larger drip set. If you have an animal that's 20 pounds or greater, heavier animals are going to be using this 15 drop per ml drip set. Okay, so again, the reason that we use the large bore needle and it's only 15 drops per ml is because you have a larger opening in this needle, so it doesn't take as many drops to make up 1 ml. Whereas this tiny little one, it's going to take a lot more drops to deliver 1 ml. And so we use that for our smaller animals. So we're going to start off with our surgery infusion rate, and we'll go through the steps here. The one thing that I always like to do is write out the information that I need to know whenever I'm given a problem. So the first one is the animal's weight. I always write the animal's weight up at the top of my paper. I always choose a drip set, which is based on the animal's weight, which we just went over. You're going to choose the 15 drop per ml or the 60 drop per ml. And then I'm going to set up dimensional analysis, or if you like ratios and proportions better, that's fine, for the animal's weight and the standard rate for surgery infusions. So this is my third piece of information that I need to know. You must memorize this. 4 mLs per pound per hour is the surgery infusion rate for an animal. So after we have all of these pieces of information, we multiply or do our ratios and proportions. We find mLs per minute using our drip set, putting that into our calculation. We will get drops per minute, and then we're going to convert our drops per minute to drops per second, and then we set our drip rate on our IV bag. So let's do an example here. So if we are to set up this surgery infusion example here, we read it out first. A 74-pound dog needs to be castrated. Calculate the infusion rate of fluids while the dog is under anesthesia. So the first thing I'm going to do is kind of write out my pieces of information that I know and that I need. So I have a 74-pound dog. Now the second thing I want to do is choose a drip set based off of this animal's weight. So this animal is 20 pounds or over, it's 74 pounds. So I'm going to be choosing the 15 drop per ml drip set. All right, so then the last piece of information I need to know, we're doing a castration, so we're obviously doing the surgery infusion. So we need to use our surgery infusion rate, which is 4 mLs per pound per hour. So now I can start setting up my infusion rate calculation. So what I'm going to do is I'm going to take my 74-pound animal. I'm going to multiply the 4 mLs per pound, and to spread it out, we'll do per hour. That's what that is, 4 mLs per pound per hour. And that's going to give me, my pounds are going to cancel here. That's going to give me mLs per hour for my units. So if I were to take 74 times 4, that's going to give me 296 in mLs per hour. Now what it's asking me to find here is mLs per minute. So what I need to do is take 296 mLs per hour, and I'm going to use a conversion factor to get from hours to minutes. So what I need to ask myself, is there a connection between hours and minutes? Perhaps how many minutes are in an hour? So what I would do, there are 60 minutes, in an hour. So what I'm going to do is set my hour, 1 hour on top here, and 60 minutes on the bottom. And the reason I set it up like that is so that my hours cancel out and I just have mLs over minutes for my units. If I were to switch it around and put 60 minutes on top and hours on the bottom, that would give me mLs times minutes over hours squared. And that's not what we're looking for. So we need these hours to cancel out, and then we can do our problem here. So we have 296 divided by 60, which is going to give us 4.9 mLs per minute. Okay, so we found our first question here. So keep this in mind. This would be an answer on your exam, perhaps. All right, so now we need to finish the problem because we have to find drops per second. And we find this because it's easier to count drops in seconds than sitting there for a whole minute trying to count drops. And then if you don't have the right number of drops in that minute, then you're taking up another minute. It could take you forever to set a drip rate if you're doing it in minutes. So we do it in seconds. So what we need to do next is take our 4.9 mLs per minute that we just found, and this is where we plug in our drip set information. So our drip set is going to be 15 drops per ml, and I set it up like this so my mLs cancel. But look, I'm still left with minutes, so I need to get from minutes to seconds. So I'm just going to continue my multiplication line here, and in 1 minute, there are 60 seconds. So now I look around and I say, all right, mLs cancels out, minutes cancel out on the top and bottom. I'm left with drops per second, which is what I'm looking for up here. So now I just multiply across the top, divide what's ever on the bottom, and I'm going to come up with 1.2 drops per second. Now, interesting, can we count 1.2 drops coming through a drip chamber? Not really. We can only count whole drops. We can't count half drops or 0.8 or anything like that. We can only count whole drops. So we don't round this necessarily because we want it to be accurate, giving it to the animal. So what we do is we'll multiply this by a number that will end in 0. The answer will end in 0. So for instance, what I usually do is I look at my, let me get another pen here. I look at my number that is to the right of my decimal point if I have a decimal in my number, and I say, okay, 2 times what is going to give me a number that ends in 0? 2 times 1 is 2, that doesn't end in 0. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. Well, 10 ends in 0. So what I'll do is I take 1.2 times 5, and 1.2 times 5 gives me 6. 6 is a whole number. So what I have is 6 drops in 5 seconds. And I got this 5 seconds from the number that I multiplied by. So basically what we're going to be doing is in a 5-second period, as you watch the clock or watch the second hand on your wristwatch, you should be counting 6 drops coming through that drip chamber. So we count 6 drops in 5 seconds. So 6 drops in 5 seconds is going to be our answer in drops per second. Okay? So let's try another example. You're going to try this one on your own, but instead of using 4 mLs per pound per hour, Dr. Meckel actually likes to use this one, which is the same thing as 4 mLs per pound per hour. It just has kilograms in here. So what you need to do is convert your 15 pounds to kilograms and place this in for the 4 pounds per ml, or 4 mLs per pound per hour, okay? So just replace 10 mLs per kilogram per hour with 4 mLs per kilogram per hour, okay? So I want you to solve this on your own, and you should get, in mLs per minute, you should be getting 1.1 mLs per minute. In drops per second, you should be getting 11 drops in 10 seconds. Okay, and your drip set, you should be able to figure this out. It is a 15-pound animal, so you should be using the 60 drops per ml drip set. Okay? Okay, so let's move on to fluid replacement therapy. So an introduction to fluid replacement therapy, it's pretty simple. Fluid replacement therapy is exactly what it sounds like. You are replacing fluids into an animal that is perhaps dehydrated because of stress or trauma or just regular old dehydration. So when we are calculating fluid replacement therapy, we are basing it off of percent dehydration. So your doctor will tell you what percent dehydrated this animal is, and that is how you are going to figure out the amount of fluids to give to this animal. So fluid replacement therapy, there is one main step that is different in fluid replacement therapy, and that is step number 3. Step number 1, again, we have our animal's weight. Step number 2, we're choosing a drip set based on the animal's weight, just like in our surgery infusion rate. Step number 3 is the one that is different, because for fluid replacement therapy, you're usually giving this in emergency situations. So what you need to find is the total fluid volume to give in one day or a 24-hour period. And so in this total fluid volume to give in a day, we need to figure out how many fluids need to be replaced, what is the normal amount that an animal would consume in a day, the normal amount of fluids, so that would be our maintenance, and then the total, which is adding replacement plus maintenance and getting our total for a 1-day period or a 24-hour period. After we find that, we do the same thing we did in the surgery infusion rate, which is finding mLs per minute, finding drops per minute and drops per second to set our drip rate on the IV fluid bag. So when we're finding total fluid volume, we have to find 3 different things to give us our total fluid volume. Actually 2, and then we just add them together at the end. So we need to find the amount of fluids that need to be replaced. So we determine that by seeing how dehydrated they are, what percent dehydration they have, which again, usually given to you by the doctor. For our purposes, you're being given the percent dehydration by me. So to find the amount of fluids that need to be replaced, we take the weight in kilograms, make sure you know it's kilograms, times the percent dehydration. Percent dehydration, you do need to convert this to a decimal number first before you multiply the weight in kilograms. So weight in kilograms times percent dehydration, you're going to get a volume in liters because this animal is losing so many liters per kilogram. So percent dehydration is for liters per kilogram. What we need to do once we find our answer in liters is we need to convert the answer to mLs. So you're going to do that by multiplying by 1,000. So you take your volume in liters times 1,000, or you can just move your decimal point 3 places to the right for our purposes here. Okay? To find maintenance, what we're going to do is determine the amount of fluids required for daily maintenance. Now, usually, animals, dogs and cats specifically, will drink or consume about 40 mLs per kilogram of that animal's weight. So 40 mLs per kilogram is going to be our maintenance amount that we're going to multiply by the weight of the animal in kilograms. So weight in kilograms times 40 ml per kilogram gives you a volume in mLs, and that's because our volume is in mLs here for our maintenance rate. Now, once we get both of our answers for replaced and maintenance, what we're going to do is add them together, and they need to be the same. So that's why we can't leave our replaced amount of fluids in liters. We need to change it to mLs from liters. So mLs plus mLs, and we will get our replaced plus maintenance total fluid volume for the day. So R plus M in mLs is going to give our total ml per day. Now this is just the third step of the fluid replacement therapy calculation. The rest we also need to figure out. So this is this is kind of like a sheet that I used to make for myself to make sure I got all of the information for fluid replacement therapy infusion rates. So what I would do is I would take the animal's weight in pounds and then determine it in kilograms, make sure I had chosen the correct drip set, and then wrote down the volume in mLs for replaced, maintenance, and then total. And this total again was mLs per day. Okay, then from there I need to find mLs per minute, then to drops per minute, and then drops per second. So let's give this a try. So we have a 74-pound dog that is 6% dehydrated. So what I'm going to do, again, I'm going to take all of my information that I know, and I'm going to write it down. A 74-pound dog, and remember, you want to change 74 pounds into kilograms. So 74 divided by 2.2, which is our conversion factor to go from pounds to kilograms, is 33.6 kilograms. Okay, so now we see here that we have a 6% dehydration. So I'm just going to write that over here, and then a 74-pound dog is greater than 20 pounds, so we need to use the drip set 15 GTT per ml. So now we're ready to start our problem. Remember that we need to figure out R for replaced, M, and T for total. M stands for maintenance. So for replaced fluids, how do we find the amount of fluids that need to be replaced in this animal? We take their weight in kilograms, and we multiply it by the percent dehydration, which is 0.06. Okay, now our answer for this is going to be 2.016 liters. Remember, this is in liters. Now to change this to mLs, which is what we have to do, we multiply by 1,000, or move our decimal point 3 places to the right. So this gives us 2,016 mLs for R. Okay, now for M, we take our weight in kilograms times 40 mLs per kilogram. When we take 33.6 times 40, that gives us 1,344 mLs. So 1,344 mLs. Now what we're going to do to get our total is take the amount of fluids from replaced plus the amount of fluids from maintenance and add them together. And this gives us a total of 3,360 mLs per day, or per 24 hours. Okay, so this is our number that we start our problem with. You're only halfway done at this point, so don't stop here on your exams, okay? So this is our number for total total daily fluids. So we're going to take our I'm just going to write this up here, 3360 mLs per day. All right, and I'm going to erase the rest of this over here, come back and look over how to do RMT if you did not follow that well. So just go over it again. Okay, now the second part of our problem, we need to find mLs per minute. So what we're going to do is take our 3360 mLs over, and I'm going to put 24 hours up here because 24 hours is 1 day, so they're the same thing, and hours is easier to convert to minutes because I'm trying to find mLs per minute. So in 1 hour, there are 60 minutes. So my hour units are going to cancel out. Remember, I'm setting them up so that they cancel. So 1 hour would go on top, 60 minutes on the bottom. That's going to leave me with mLs over minutes. So when I calculate this out, I get 2.3 mLs per minute. So there's the first part of my problem. So 2.3 mLs per minute. So I'm going to come down here and I'm going to start finding my drops. So 2.3 mLs over 1 minute. And this is where I insert my drip set, which I've chosen a 15 drops per ml. And again, I'm going to set it up in such a way that makes my mLs cancel out. And I'm also looking for seconds, so I can just keep this problem going and say in 1 minute, because minutes is on the bottom over there, so it needs to be on the top on this line, there are 60 seconds. So we have 2.3 mLs. Our mLs are going to cancel out here. Our minutes here and minutes up on the top are going to cancel. That leaves us with drops and seconds, which is our ultimate goal to find so that we can set our drip rate in drops per second. So we take 2.3 times 15 and divide by 60, and that's going to give us 0.6 drops per second. Now, can we count 0.6 drops per second coming through our drip chamber? Absolutely not. We cannot do that. So we're going to look at our 6 and say, because what we need to do is try to get it to a whole drop. So we look at the 6 and we say, okay, 6 times what is going to give us a number that ends in 0. 6 times 1 is 6, 6 times 2 is 12, 3 is 18, 6 times 4 is 24, 6 times 5 is 30. Oh, 30 ends in 0. So we're going to take 0.6 times 5, and when we do that, we get the number 3. So the number 3 is our drops, and we are counting 3 drops in 5 seconds, and that's because we multiplied by 5, so that 5 sticks with our seconds. So we count 3 drops in 5 seconds on our IV fluid bag. Okay, so what I would like you to do is try these next 2 examples. And for the first example, you should get 1,482 mLs per day for the total amount of fluids. You should get 1 ml per minute for mLs per minute, and you should get 1 drop in 4 seconds for your drops per second drip rate. Okay, for the 12-pound cat that's 10% dehydrated, you should get, for the total 770 mLs per day. You should get 0.5 mLs per minute. And for the drip rate, you should get 1 drop in 2 seconds. Now, these are separate. Okay? All right. So now, after this 12-pound cat that's 10% dehydrated, the rest of the problem says after we stabilize and rehydrate the 12-pound cat, we decide to proceed with a necessary ovariohysterectomy surgery, which is a SPAY. What will the infusion rate be for the cat undergoing the surgery? So you figured out how to stabilize the cat. You're going to be giving 770 mLs per day and set the drip rate for 1 drop per 2 seconds. Once you stabilize the cat on that amount, you're going to redo your calculation for the surgery infusion rate. So again, you're using your 12-pound cat. Your surgery rate is 4 mLs per pound per hour, and choose the correct drip rate, or drip set, for the 12-pound cat. So I want you to try this out. You know, you're doing a completely separate calculation for the surgery rate, okay? So your fluid replacement therapy is 1. You should come up with this answer. For the surgery rate, you should come up with a completely different answer and a completely different drip rate and drops per second, okay? And you're using this rate. You don't have to find RMT or anything like that. Okay, so it's like the first few problems we did with the surgery rates. So your answer for this should be 0.8 mLs per minute, and the drops per second should be 4 drops in 5 seconds. Okay, so again, please let me know if you have any questions about how to do these. I know this can be a very long process, and this takes a lot of time to understand and really realize how to formulate your problem and calculate it correctly. But please let me know if you have questions. You can email me. Please come into the chat and ask me questions on Tuesdays and Wednesday nights. And yeah, you can always stop by during my office hours too. So please let me know if you need help. I'm more than happy to help you. Okay, thank you very much and good luck.